Okay, everybody, welcome back. I wanted to do another really quick video, and this time I just want to focus on using radicals, or polyatomic ions. I am going to use some of the just simple elements from the periodic table as individual positive or negative ions, but I want to give a little bit more exposure to this. So, all right, let's pick something. Let's pick something which you may not have seen before. I'm going to give you an ion, and this is an ion from boron's group. This is aluminum, and aluminum forms a +3 ion. And I want to make a compound with, I mean, you can probably look on here, and this is not the ion sheet that I gave you, but you guys can probably find something. Is there anything that would match up with a +3 right now? And it turns out there's a couple. We have a couple -3 charges. So let's use phosphate. And phosphate as a whole, all right, the PO4. And remember, the charge that you see there for phosphate applies to everything on the inside. So phosphate's a -3. And then the only question you have to ask yourself is, do you have a positive charge? Do you have a negative charge? Yes, I do. Does the positive charge and the negative charge added together give you 0? And if the answer is yes, then you have a compound. So to write the compound, remember, we don't write in the charges. We just write in the chemical formula, and we add in any subscripts that might be necessary. So for this particular chemical formula, all I need is the Al, and then the PO4. Now, this is where the debate starts. Do I need to put parentheses in here or not? Okay, and here's the deal. If you only have one of the polyatomic ion or one of the radical in your formula, you do not. In this case, I only need one phosphate to balance out the +3 charge of the aluminum. So for this case, I don't need the radical. So I think I just said you don't need the radical. For this particular case, you don't need parentheses around the phosphate. Okay, well, some people, when you're first starting out with this, you say, oh, I really don't like that. Can I put parentheses around it if I want to? Yes, there's technically nothing wrong with it. Technically, if you don't see a number next to something, technically that means 1. But this is something for beginners especially, it can be really confusing. Why don't I write a 1? Well, it's just something we do. Technically, you could also put a 1 there by the aluminum because you only have one of those in the formula. So I guess for pro users, or for advanced users or writers of chemical formula, you technically don't need those things. All you need to have would be Al and then PO4. So let's do something where you actually do need to have parentheses. And in fact, I want to stick with phosphate. Okay. Okay, so I've rewritten phosphate down here, and when I start off, at least initially, I have the charge up here. I have parentheses around it. So now I want to pick an ion, and I'm going to go back to the periodic table and dig up a +2 ion. Now, I pick calcium. Calcium's a +2. And if you're in your heads doing the math, a +2 and a -3, they do not equal 0. So I have to do something here. I have to add additional ions. And in this case, I want you to kind of look carefully here. I've got kind of a situation where if I decided just to add one more calcium, right? If I add one more calcium, I'd be at a +2. What would I have here? I'd have +4 and -3. That still doesn't equal 0. So if you go back to your math class and you remember anything about evens and odds, you remember the thing called, I believe it's called LCM, and don't quote me on that, it's been a long, long time. Lowest common multiple, least common multiple, something like that? Is that ringing any bells? What's the least common multiple between 2 and 3? And I'm hoping you guys are going to say 6. So now the question is, whenever you run into a situation where you have an even odd type of thing, you need to use this. All right, it'll save you some time. So what's the lowest common multiple? We said 6. Okay, so how do I get this side here to be a 6? Well, that means I'd need 3 calciums. So I'm going to put a calcium there and another calcium here. And that looks like a CO. There, now it's a CO. So I have +2, +2, +2. Overall, that gets me +6 on this side. How do I get to a 6 over here? Well, I'm going to need 2 phosphates. Each phosphate, I'll put another phosphate over here. Each phosphate's a -3. So if I have -3, -3, I end up with a -6. Now the analysis works. plus 6 and a minus 6 gets me to 0. And now I can write a chemical formula. But I've got to include all of this stuff. I've got 3 calciums, I've got 2 phosphates. So let's write that. We start off and we write the very first element we have here. Remember, typically the metal ion goes first. And all I'm going to do is write a subscript here. How many calciums do I have? 1, 2, 3. So I'm going to write a 3 as a subscript. And then now we're going to have to deal with the phosphates. Okay, now take a step back. Remember what we did over here. Here we said we don't need the parentheses because I only have 1 phosphate. Do I have 1 phosphate here? Nope, got 2. So now I have to use parentheses. I'm going to put a P here. There's my PO4. And I'm going to put an end parentheses. And now I have to put another subscript. How many phosphate ions do I have in this formula? You guys could count 2. So I'm going to put a 2 here, and that's it. You've written a complicated chemical formula for something with a polyatomic ion. Okay? I want to do one more example. If you look on here, there's one polyatomic ion that actually has a +1 charge. And I think you guys can find it right here. So I'm going to do an example with that right now. Okay, so if you notice, a polyatomic ion of NH4 stands for ammonium. Not ammonia, not pneumonia, the disease you get. It's ammonium. And if I start off, this is actually going to act as the metal ion. So I have NH4, and then that whole thing is a +1 charge. Well, I actually want to make a compound here with 2 polyatomic ions. One of them is ammonium, and the next one, let's pick something. Eeny, meeny, miny, mo, blah, 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 blah. How about right here? How about something in the minus, I don't know. How about sulfite, all right? Nothing wrong with that. So I've got SO3. Remember, sulfite is minus is SO3, sulfate is SO4. And in this case, the whole sulfite is a -2. All right, so, in a way, forget everything you're seeing inside each one of these because it can be confusing. And just look at the math. What do I have to do with a +1 and a -2 to get me to 0? Good. I've got to add another NH4. And that's exactly what I'm going to do with the chemical formula. I'm going to add another NH4 +1. So how do I write it? Do I have to use parentheses? And where do I have to use parentheses? Well, I've got 2 ammoniums. So that's the place where I'm going to have to use parentheses in this case. I've got NH4. Uh-oh, I forgot my subscript in here. NH4, and then it's got the subscript 2. And then how many sulfites do I have? Only 1. So in this case, I don't need a parentheses. All right, so SO3. So I have ammonium sulfite. It's a little messy. I hope you guys can read my handwriting. But anyways, this is just a little bit more on the kind of advanced chemical formula writing. Now, to date, we've only talked about kind of ionic formulas, but we will start talking about how to write covalent formulas. They're a little bit different. All right, that's all for today. I'll see you.